What is showing on your monitors is a section of a tabulation table for the survey questionnaire for women of reproductive age. Let's go over the contents of this particular tabulation table. As you see, you will see that we have spaces for recording the supervision area that is being completed, the name of the supervisor, as well as the date for this particular exercise. The table also includes many columns. We have a column for the indicators. We have also another column for the correct response key that will help us to coding which answers will be correct and which answers will be incorrect for each of the 19 samples that we are going to collect from each of the supervision areas. You should also see that in this particular row we have some codes that will help us coding correct answers, incorrect answers, as well as skipped questions and missing answers. So in all these small cells that you see here for this particular indicator number 1, age of mother at first birth, we will collect and code the correct answers, incorrect answers, missed ones, or skipped ones. Once we have all these numbers coding correctly, we should be able to get the total number of correct responses in this particular supervision area for this particular indicator, and then we should be able also to obtain the total sample size. Let's take a closer look at an example with some numeric values so we can better understand this particular table. As you can see in this particular example, we have the tabulation table with some codings already filled in, that is ones or zeros or 1x for this particular interview number 7. So we are looking at just one particular indicator, the age of mother at first birth, and we're going to use this particular correct response key, those between the age of 20 to 35 years old, in order to go to extract the information from the questionnaires and coding those answers into all these cells that we are showing here. For this particular example, we have 14 correct responses, and this is getting based on the number of ones that have been already coded for the 19 responses that we have collected in this particular supervision area for this particular indicator. Likewise, we are able to get the total sample size, which for this particular example is 18, that is obtained from adding all the ones and zeros. The x's, which are the missing points, are not included in this particular number for the total sample size. After completing a tabulation form for all 19 responses obtained and for all the supervision areas, we will make use of a summary tabulation table that we're going to show up in your monitors next. The purpose of this summary tabulation table is to calculate coverage rates of the indicators being assessed for the entire catchment area, that is from all supervision areas. We will be able to calculate these coverage rates by extracting the total number of correct responses from the previous tabulation table and the sample sizes from each supervision area. Once we have the total number of correct responses from all supervision areas and the total sample size, we will be able to calculate the average coverage, that is the total number of correct responses over the total sample size. This is the average coverage that is included in the very right-hand column of this particular table. This summary table We'll also have cells to include decision rules for each supervision area. As you may recall from lecture number 1, once we have the average coverage for the entire program area and the sample size for each of the supervision areas, we can determine decision rules. And the decision rules will be recorded right in this particular row, just underneath the row where we're going to put the correct responses in each of the supervision areas. Identifying decision rules per supervision area is necessary simply because in real-life projects we may not always obtain the optimal sample size of 19 for each question in each supervision area. We will use the decision rule per supervision area in order to classify whether that particular supervision area is at high risk or at low risk for the indicator being analyzed. Let's take a look at another example with numeric values so we can better understand this particular summary tabulation table for this example from a baseline survey. What you see here is an example of a summary tabulation table with some numeric values for the first indicator that we're looking at under Section 3 of Family Planning, that is age of mother at first birth. As you can see, the numeric values of 14, 15, 10, 17, 15, and 18 correspond to the total number of correct responses in each of the 6 supervision areas for this particular example. That is why we're able to obtain 89 as the total number of correct responses in the program. At the same time, from the previous tabulation table, we should be able to extract the sample size per supervision area. With all this information, we should be able to calculate the total sample size in the program. And with these two parameters, the total number of correct responses in the program and the total sample size in the program, we should be able to calculate the average coverage, which for this example results from dividing 89 over 111. That'll be 80.2%. Now, once we have this average coverage, we will go back to the LQAS table for decision rules and use this average coverage and the sample sizes in order to identify decision rules by supervision area. That's the reason why this particular summary tabulation table has an extra row for this indicator number 1 that is underneath the total number of correct responses. So the 13, 14, 13, 14, 14, and 14 correspond to decision rules per supervision area. And you see that there is a variation in a couple of those simply because we did not have a sample of 19 in supervision area 1 and supervision area 3. So once again, with this average coverage rate of 80.2 and with the sample sizes from each of these supervision areas, we are able to calculate all these decision rules. This is going to be key information for us when doing the analysis at the supervision area level, because this will help us to classify which supervision areas are at high risk and which supervision areas are not at risk.